Well, hello everyone, and welcome back to Adrian's Digital Basement 2. This is episode number 2 of the Turbo Mail Call series. So I came up with that name after I edited and after I shot the first video, which is why I never mentioned Turbo Mail Call in that first video. But it's on the thumbnail because I sort of thought of it when I was editing. I thought, oh, that's kind of catchy. So that's what we're going to call this series. And what Turbo Mail Call is just me trying to get through the backlog of mail call packages that I have. And in the last episode, which was the first one ever, I had something from 2023 and another one from 2024. So some of the stuff that's in here is just really old. And I just want to explain myself, by the way. Especially the little packages, I would just put this in a big box. I had a big box that just held all the little packages. And then when I would make the old super mini mail call episodes, I would just go and grab packages randomly. There wasn't any kind of like first in, first out kind of thing. Therefore, stuff just sort of fell through the cracks a little bit. So I'm not sure if there's stuff that's in here that's also very old. It's possible. The place I use for a PO box puts these stickers on things and that has dates on it. So it makes it really helpful and easy for me to know when I got stuff. Like this package right here. This is only a few months old. Now what you see on the table is pretty much everything that's left that I haven't opened. In the last episode, I got to 16 items, which is certainly more than I ever used to get through with a regular mail call episode. And that happens because I just go a lot faster in this Turbo series. Less time focusing on each item, just sort of quickly looking at the letter, looking at the items and putting it in a spreadsheet. I'm keeping track of everything I open. And then I will be focusing on this stuff more in depth at a future time. Now everything that's here, like I said, is everything that I have left, except there are 3 more really big packages over there under the stairs. So I will need to get to those as well, probably at the end. Although maybe I should open those first, because if I do, then I can make that space for storage. Although, no, let's get through the small packages, because this is stuff that's really been languishing for a long time. So I want to get to this stuff, and then we'll do the larger packages. And then there's one more little caveat. I mentioned this in the first episode. I do have some footage of opening mail call items that are from like 2, 3, 4 years ago. And this is stuff that never got fully turned into a normal mail call video. I used to shoot videos in 2 segments where I'd open them. The camera was like further away from me. And then I would do another bench segment. You know, let's take a look at this on the bench, edit that stuff all together. Well, I never shot the bench segments. I only have the opening footage. So I need to revive that footage. I still have it on my NAS and see if it's suitable for one of these Turbo episodes. I might append it on there, or I might need to just shoot some additional footage of the on the bench part that I never did, or something. I don't know. I need to figure out what to do with that. I haven't looked at that footage in a number of years, but the projects are still there. They're just unedited. So that's another to-do item. So there's stuff that if you've sent in and you haven't seen it on an old Super Mini Mail Call episode, or even an original Mail Call episode, or any of these Turbo episodes, it's because it's in that footage. Don't worry though, the footage I still have, the items I still have, and everything is on my spreadsheet that I will be updating on my laptop for this video. So I have all the information at my fingertips to turn that into a good episode. I just need to do that. Plus I can remove these old projects from my video editor, stuff that's like been lingering about, things that I've like started and never finished. All right, this intro is super long. Let's get over there to the bench and start opening packages. Just like last time, I'm doing this at night, so it's a little bit of an after dark episode. All right, let's get to opening packages. Let's just grab the first one right here. This is one I've already opened because occasionally things come that don't say mail call on it, like this one. Although it might have said mail call, I think my PO box stuck a sticker on top of it. But I can tell the date, and this is from 2024, so this is about 1 year and 3 months old. And this looks like a very inexpensive oscilloscope. Looks like this one is made by Ziwi. Digital oscilloscope, the DSO 154 or 154 Pro. There it is. Oh yeah, this is a cheapy thing. Included with this. Oh yeah, that's a. I guess that's the tilting bail. So you stick that there, and then you can tilt this up on your bench. We have a very inexpensive probe. It looks like 100 megahertz, 10x. There is this type of a probe, or clip leads that is, to a BNC, and this is USB-C. I've done a number of videos where I worked to repair something like Commodore 64. Oh, there's a battery. I just noticed the battery in there. Okay, let's see if this turns on. It may not turn on at this point. Oh, it does turn on. Well, it made a clicky noise. It's got a relay in there. That is the power button that I was pushing. The battery is so dead it can't turn on, so we need to let that charge for a little bit. Now, as I was saying, I've done a number of videos where I've repaired Commodore 64s using very inexpensive oscilloscopes. And I recall I had a viewer who emailed me and said that they were going to send this to me so to see what I thought of it and if I could do a repair like on a 64 using something like this. We're going to have to look up if this thing is still available because it's from 2024. And we'll have to see how much it costs, because obviously I think this existed before. I'm just grabbing the Zoe that of course I've used so much on the channels. These are like about 80 bucks shipped right now. And I really like that scope because it's a 2-channel scope and it's got a big screen and it's quite capable, and it's a decent multimeter as well. So this will need to be something like 30 or 40 bucks to even compete. It's not a multimeter. Looks like it has a little signal generator of some kind. Yes, it does. Single channel, obviously. So bandwidth, it claims 18 megahertz and 40 megasamples a second. I don't actually know what the Zoe is. So we can put this all the way down to 10 nanoseconds as the time base. And you can see here that this has a time base minimum of 50 nanoseconds. So it's definitely, yeah, this goes down 2 more notches lower. So there's 50, 25, and 10. This Zoe is not an exceptional oscilloscope, but it's completely good enough for fixing most old 8-bit computers. You don't really need high-speed oscilloscopes to do that. The problem is 18 megahertz, which this is what this claims to be, that's a little bit on the limit, because on a lot of 8-bit machines, it uses like a 14 megahertz crystal, and then that gets divided down. If you're trying to look at that stuff, 18 megahertz, that's really, no, that's too close. Usually you want to have something like double the bandwidth to be able to work on stuff that's running at 14 megahertz. And the computer's not 14 megahertz, of course, just that crystal is, and it gets divided down to 1 megahertz and 3 point whatever for the VIC-2 chip. So it may or may not be appropriate. Is this thing, oh, it's not even charging anymore. Oh, you know why? I think this turned off. Okay, I'm gonna have to plug this into something else, and we'll have to come back to this to see if this even works. So I did a quick search for the DSO 154 Pro, and there it is. So it's $40, free shipping, and that's US tariffs included. My problem with these types of scopes is that they typically have software-based triggering, and that's just not good enough. It's not going to work as well as something like this. And if you can basically spend $40 or double it and have 2 channels and a good multimeter and a good screen and, you know, a good durable form factor, like this thing is dropped on the floor and it doesn't break, I will be skeptical if this is going to be particularly usable compared to something in the price range of this. Bandwidth 1 megahertz or 18 megahertz optional. Trigger types auto, normal, and single shot. So that is the same as this. It doesn't say if it's like a hardware trigger or not. So it says there's 2 versions. Which is this? Oh, okay. You got to pay $51 for the 18 megahertz version. So I'm even more skeptical at this point. And this is really why. So if we take a look at these Zoes here, so this actually ships from the US. Is this 703? Yeah, that's this one. It's only $60. Free shipping as well. It's going to be a tough sell to try to compete with this. Now that could be the special price, because I think these are normally around $80. In fact, you know, these other ones are quite a bit more expensive. So it could be that this one's on sale or it doesn't come with something. I don't know why this one is so cheap. Looks like it comes with at least 1 scope probe, maybe not 2. It does talk about the fact that this is 50 megahertz, so that's significantly more. And I know the bandwidth is not great on here, but it's certainly enough for working on any Commodore 64. 280 megasamples per second, which I already forgot what this one claims it is. This one says 40 megasamples per second and, you know, 18 megahertz for the top bandwidth one. I don't know which one came in the package just now because it doesn't really say anything like what bandwidth this one is. But I still can't believe the price here. It says this ends on January 7th, and that's for the 703S. That's this exact one. 2 probes, multimeter leads. They're not very good. These are different ones I'm using here. USB cable and a carrying case. $60? That's unbelievable, actually. And just looking at this again, this one does say Pro on here. So does that mean that this is the 18 megahertz version? Quite possibly. battery not swelling or anything? Okay, the battery looks fine, luckily. Yeah, I think it's just completely dead. So I'll have to charge this for a while. All right, so I'm gonna plug this back in, let it charge. Hopefully it will turn on, and then at least we can see what the bandwidth is on this. And if it's the 1 megahertz one, unfortunately, I'm gonna pretty much say that it's not usable. But if it's the 18 megahertz one, then I'm gonna put this aside and I'll try to do a future repair video. But for $51 for the 18 megahertz version, which would be the bare minimum to do any kind of repairs, for a few more dollars, you can get this. And I'm sorry, there's zero competition here. The Zoe absolutely blows this thing away, and I haven't even turned this on, just from the features and the capabilities and durability and all that stuff. So anyways, okay, let me plug this into charge and we'll go to the next item. All right, this is the next package. Oh, here we go. We have a letter and, oh, a little PCB. Greetings, Adrian. It was great to meet you last fall at the Interim Computer Festival up in Seattle. There's another one in March. I hope you can make it. Yeah, I think I went to this. There was no date on this, so I'm not sure when I got this. Thank you so much for trying out my Smart Disk 2 design. So this must come from Brad Bell up in Seattle, and Brad has done a ton of awesome open source peripherals or cards for the Apple II. Featured a bunch of them on the channel before. I think 80 column card, floppy drive controller, Smart Disk controller. It's all open source. You can go to the GitHub link and download that stuff, make it yourself. His stuff is just a great source of these Apple II cards, which are now getting more expensive and harder to find. So it's just nice to be able to make them yourself. Oh, RAM expansion cards, including the language card for the Apple II and the II Plus. So all sorts of great things. Let's see what it says here about this card. The Apple II joysticks are pretty foreign by the standards of most older systems. So adapting them to one another's usually involves a good number of logic chips or even microcontroller. I don't really like that way of doing it, so I followed the lead of the NES 64 from autumnhippo.com. You showed one on your channel a couple years ago and made this replacement PCB, which only needs a handful of resistors and should work with any NES or clone controller. Unlike Apple II joysticks, NES controllers are not analog, and my board just uses the D-pad to apply a fixed signal to the appropriate of each axis. So the conversion won't work for software that actually needs analog control, but lucky for us, most Apple II games don't. Thanks again, and I hope you enjoy. Okay, awesome. This is a thermal paper printout, so I'm glad I didn't have this for so long that it didn't fade. So we can tell this PCB is designed to go inside an NES controller. And if I go and grab one of my controllers, here we are. Here's one. This one has been modified to actually work, wow, it's grungy looking, to work on things like the Atari and Commodore 64. So if we follow the cable to the end, it's got one of these now. And the way I did that is, it is an original NES controller and it is original NES PCB in here, but I just changed out the cord and I connected this directly up to the pads where these buttons are. So there's a shift register in here that just doesn't do anything anymore. Well, this is a replacement PCB that you could put inside a controller like this, but instead of it only working on digital systems like the Atari or the Commodore, this will use some resistors, and I can see little resistor networks here. So we'll need to find a GitHub repo, maybe on the back it talks about it. And then when they connect a cable to this, it would go out the controller right here and then be able to plug into an Apple. And that would be amazing. I would love that because I don't even actually have any good Apple joysticks. I have analog ones and I hate them. Okay, so there's the pinout. Brad had to update that. For conversion of NES controllers, oh, I see, we can install actual resistors or surface mount ones. Very cool. So all 1Ks and 268Ks, super easy. Third and fourth buttons, select and start, are not usually supported on the Apple II, but the pads are provided for your convenience. So it looks like the pinout has 0, 1, and 2, and it looks like we actually have connections all the way up to switch 3 right there. And we can see it's those first 4 resistors. And that actually hooks up, yeah, A, B, start, select. So those are all connected up. Well, I gotta say, this is really cool. And I didn't know it was as easy as just connecting resistors to make it work on the Apple II. I don't want to modify this controller since I use this on the 64 and anything else that's a digital input, but I need to find another NES controller and I guess swap out this board and then just find a cable that has the appropriate D-sub connector on the end. And then I will have an NES controller that works on the Apple II. The only thing I have feedback on, Brad, is that these pads, when they're just this tinned look to them, I don't even know what coating this is, they're not reliable long term. What will happen, and I've had this before with some of the other PCB replacements for these, is the buttons just sort of stop working properly after a while. And I don't remember when you gave this to me, I can't remember, but have you been using one of these long enough to experience that particular problem? I think this stuff just gets oxidized enough that the pads in here don't work reliably. And I'd have to imagine that if this PCB were made with that ENG coating, that's like gold looking coating, that you probably wouldn't have that particular issue anymore. This is the original NES PCB, you know, from the 80s and still works perfectly without any issue. So thank you, Brad, for making this. I'll try to find the GitHub repo while I'm editing, and I'll put it up or a link or whatever. So if there is one, I'll stick it there. There isn't anything written on here for GitHub, so I don't know if this is available, but everything that Brad does is open source hardware and the logo is on there. So I assume this will be available. And if there's anyone out there who likes to use D-pads on your Apple II, then something like this could potentially be awesome. And I'll certainly be doing this. I'd like to play more Apple II games, but the biggest problem for me is I hate those stupid analog joysticks that's all that's really available for them. So I really like having a D-pad. All right, let's just grab the next package. This package is from Aaron over at Retro Hack Shack. If you haven't seen Aaron's channel, I'll put a link to his channel down in the description below. He's got a store where he sells a bunch of cool open source hardware projects like RGB to HDMI and other stuff as well. Inside we had, looks like an RGB to HDMI again. Okay, what's all this, Aaron? The letter reads, "Hello Adrian, greetings from Retro Hack Shack. As we discussed, I've sent a new audio board and cable for the RGB to HDMI, which combines an audio signal into the HDMI output. This is by far the most requested feature I've ever received. Ian B, he's the person who maintains the RGB to HDMI project these days, has done some amazing work to get this board small enough to fit inside the case and has made it very easy for beginners to solder onto the top of the CPLD board. The wiki has the instructions if you need to see them, and there's a link to that. I've also included the HID Man USB converter that Rastery came up with. It converts a USB keyboard mouse to PC, AT, or XT for the keyboard and PS2 or serial for the mouse. Aaron goes on to say, keep up the great work with your videos, and maybe we'll even get to meet in person one day. Seems wild that we haven't already met." Aaron lives in the Bay Area, and I haven't actually been to the Bay Area in years. And I've known Aaron, you know, online at least, for a number of years, and we've never actually met. Aaron hasn't been able to go to any of the VCFs other than I think the one in the Bay Area and maybe the one in Southern California, neither of which I've been to. So that's really one of the reasons why we haven't met. Let's take a look at the stuff he sent along. So first, let's take a look at this HID Man. I'm super intrigued by this. A way to convert between a modern USB keyboard and PS2 or even XT and serial mouse has been something that I've wanted to do for a very long time. And it's actually a project I thought I was going to work on myself, but I never really got around to it. So there's that URL. I'll try to put that in the description. HID Man AXP Rev D. There's a button, maybe for configuration or reset, microcontroller. And then we obviously have the outputs for the serial mouse and probably PS2 mouse, and then the keyboard output. And then Aaron sent along a couple cables as well. So PS2 to PS2. So this would be for hooking up the PS2 mouse connection to the PS2 input on your computer. And then a second one of those cables. So this would be for the keyboard. So you're going to need to have both. Now to hook up to an XT or an AT DIN, you just need to have a simple adapter that goes from PS2 to the DIN. Also included an extruded aluminum or aluminum housing. The board will slide into that. And then we have a couple plates. That is so cool. And it looks like the button is actually a power button. I just noticed it says USB to yes converter. That's in yes, it should work. While putting this together, I'm struggling to get these screws in here. I think they're too large. Well, this one is starting to strip. Yeah, that one's already stripped. So these screws are maybe too big, or I don't know what I'm doing. I'm not sure. There we have it. I found a few screws in my little box of screws that will work. And I put some feet on there. And there it is. I'm plugging the cables into it. This is what I was talking about by those adapters that go from PS2 to a standard DIN that you would use on an XT or an AT based system. Here's Aaron's store. Let's see how much this little product costs. So Aaron seems to stock all the various bits and pieces that you would need to fully assemble this, like the one that he sent me. So the adapter itself is $49 and he has them in stock right now. And then if you want to add on the case, that's an extra 20 bucks, which isn't a bad deal, all things considered, since this is all metal. Aaron has a video on his own channel where he shows this off and talks about it. And here's what it can emulate. So it emulates the XT keyboard, an AT PS2 keyboard, an Amstrad keyboard, serial mouse, and PS2 mouse. You know what would be cool if this also had? Tandy support. There is no reason why it couldn't work with Tandy. I think the pinout is the same. It's just the protocol for Tandy keyboards, again, is different. But oh, maybe that's not the case, actually. I can't remember if the pinout is different. Now, I am curious is how do I switch modes? If this is the power button to turn this off and on, how do we go into XT mode, for instance? Of course, with this particular project, since it's open source, you can totally make these yourself. So there's a whole DIY section on the GitHub repo, and the repo even links to Aaron's store as well. Rear plate, enclosure, don't forget the screws. After assembling the unit, you'll need to install firmware. I wonder if you have to have different firmware for XT mode, AT mode, stuff like that. Okay, so for XT modes, turn on your PC, that powers this up. It powers it through the keyboard connection. Press the power button to select AT mode, or XT mode is orange, light blue or orange. It's funny that, again, there's no LED. I didn't see if there was one on the PCB or not, but I guess just pushing that will switch modes. Oh, and then for the menu settings, basically just open a text editor on your destination computer, hold down the power button, and it will type using the keyboard signal itself. It'll type into the text editor. That is really clever. So scroll mouse support, the simulate hard lock, soft lock. Okay, anyways, firmware updates, stuff like that. So it's all on there. And that is really, really cool. Next time I have an XT on the bench, especially, I'm gonna have to test this. I have a PS2 keyboard that I always use on anything that's AT or newer, something you can still just buy off Amazon. But for XT stuff, I have to bust out one of my old XT AT switchable keyboards and use that. And I'm lucky to have a bunch of those, but they're really hard to find these days, and I've accumulated them over the years, which is why I'm able to have those. But this adapter is really great if you don't have extra keyboards, you don't have space. You could plug a wireless USB dongle into this and use a wireless keyboard and mouse as well with your retro systems. I love it. I absolutely love it. And then this is the other thing that Aaron sent along. So this is the RGB to HDMI CPLD digitizer. And this is a little add-on. I guess this is how this works. It kind of sits in the correct position somewhere. And this will add or inject the audio into the HDMI signal. So here's a regular RGB to HDMI, just a standard one. And if I pop this apart, this is one I think Aaron sent me at some point. So this is the CPLD capture board. Well, one of the biggest problems with the RGB HDMI that people complained about is there's no way to get audio in. So your HDMI output doesn't have the audio signal in it. Well, with this little add-on board, then it is capable of doing that. Now, I have to do some reading to see exactly where on this board you're supposed to solder this on, but obviously I think the way it would work is you hold that down into the correct position, you attach the appropriate pins. I don't know if it's in that exact position. It probably is though, because looking how that cutout is, it fits around those pins and it won't overlap with those pins. And then you have something like this, which is obviously going to be some kind of stereo audio input, and that would attach to these surface mount pads, and then this wire will just have to come out of the case itself. This obviously digitizes the audio input, injects it directly into the RGB to HDMI GPIO pins, which are these, and then it mixes that with the appropriate firmware, of course, into the HDMI output. So this is on the back of the board, ENB, RGB to HD audio interface issue 2, JP1 48 kilohertz sampling rate, or 24 kilohertz. And there's our little ADC, PCM 1808 Burr Brown. Very fancy and nice. I gotta say, I mean, I talk about this all the time, but the RGB HDMI is absolutely one of my favorite projects really ever when it comes to retro computers. I use this so extensively all the time, especially for me, because it's really helpful to be able to capture the video output directly, and this just makes it completely possible. So this is a very nifty little add-on. So if you're using an RGB to HDMI to use one of your old retro computers, and one of the things you're missing is the audio injection, just know that it is now available, and of course you can make your own, or you can check out Aaron's shop if you want to buy one, here in North America at least. So huge thanks to Aaron for sending this stuff into the channel, and next time I'm working on an XT, I definitely want to try out this HDI man. And well, I don't know when I'm going to use this, because for my capture setup, I actually have a separate ADC that's USB and goes into my capture setup. So I don't regularly use this. And I'm a huge fan of having CRT monitors. So typically upstairs in my office where I'm actually using my retro computers, I have a 1084, I have VGA monitors, I have composite 1702 monitor. So I use those monitors with the appropriate computers. So I don't generally need to use an RGB to HDMI outside of the testing context down here on the bench. And in that case, I don't necessarily need the audio input. But I know a lot of people do use these because they have, you know, their 64 or NES with Luma code hooked up to their TV and having the audio input. That is going to be super helpful for those people. So like I said, you can check that out on Aaron's shop. Thanks, Aaron. Okay, so it looks like this thing finished charging, and I stuck the little tilting bail thing on it, so you can do that to kind of tilt it at various different angles, which I guess is useful. Let's see, so what is our time base? We're at 50 nanoseconds. Was that the limit? Yes, that's the limit. Let's get my frequency generator out. Sorry, that's a little bit dusty. All right, so 5 volts peak to peak, and that is too much for this, obviously. Let's just push auto, see what happens. Okay, it's able to show that, and it does say that it's running at 16 megahertz, and that's pretty much what this is outputting. Okay, this must be set to 10x mode. So let's fix that somehow. Funny, you can't push the arrow keys. Let's zoom in on this a little bit more so you can see what I'm doing. So it supports 100x probes. That's kind of handy. Okay, so this is that. Okay, wow. Okay, so left and right moves the little pointer. And maybe push auto. There we go. So let's adjust the frequency. So we're at 6 megahertz now, and it does say 6 megahertz, 16. So now this is outputting. I know it's really hard to see, but it says 26.9 megahertz, and now this says it's 13. So we're looking at, I guess, like what, a harmonic or whatever. It's measuring half. Let's see what happens when we push auto. Yeah, it still says 13 megahertz. So watch, 25, 23, 22, 21, 20, 19. I think this is rated for what, 18, right? There we go. It's actually able to read 20. Let's hit auto again. And it's at 19.9 on here. It's really kind of freaking out a little bit. But if we do 18 and let's hit auto. So it's doing it. 18 megahertz, and it's at 17.9. The frequency counter, of course, is just based on the screen, so it's not going to be super accurate, but that's not any different than this. This is also just the same. It's just based on what's on screen. So here's the Zoe on the same signal, and actually the peak to peak is also reading similar to this, and that might be because actually I think this might be expecting a 50 ohm load. I can't remember. There's a setting in here for that. Either way, it looks pretty similar, but we're at 50 nanoseconds, same time base as this. But of course, we can zoom in on the signal. So that's what the Zoe can do. And you see, it's still very clear, even at this time base, and it's measuring 17.99 megahertz. And since, of course, we can go up and there'll be no issue on the Zoe seeing these higher frequencies. This is actually the limit of this. It goes to 30 megahertz, and there's 30 megahertz without issue. So obviously this is higher bandwidth, but does that really matter if we're trying to fix something like an 8-bit computer? Probably not. Now we're outputting a 6 megahertz square wave, and this is what it looks like on the Zoe at the 50 nanoseconds. Of course, this kind of wire is not great for these high frequency signals, but it looks like that. A little bit of overshoot and whatnot. Let's just see how it looks on the other one with that square wave. Now this Unity generator is not the best thing in the world. So there it is. It's working. It's a little more jittery. Certainly this has a better trigger on it than this thing. Let's just hit auto, let it go through its little auto setup. This is fine. It's doing the job, and it's working better than I expected. This is obviously the Pro or 18 megahertz version, the one that's only a few dollars cheaper than this is right now. And looking through the menus real quick, I'm not going to do an extensive review of this thing right now, but it looks like it's got measurement capabilities, so that's nice. There's our triggering, so normal and auto. There's a manual level or an auto level. That's weird. It's got to be software-based triggering, not hardware-based triggering. You can see how wobbly the waveform is, and on this it was pretty much rock solid. I think that's because the trigger point's moving around here. It's not triggering in exactly the same spot every time, which is why the whole thing is jittering. Maybe, but maybe I'm wrong about that. Persistence, we have infinite 1 second and off. There's a roll mode, there's a brightness control, probes up to 100x, language setting, calibration okay, and auto shutdown. And a little signal generator, which probably does something. You can calibrate your probes with 1 kilohertz square wave, just like that. The user interface is weird because we have up, down, left, right here, and yet the menus and stuff work in different ways. This is really small. That's kind of nice. I don't love the fact that there's no case around this. So if you have this in your bag and like screws go in there, and of course there's a lithium ion battery that's just exposed. So color me surprised. This thing I think is better than I expected it to be. 40 bucks for the 1 megahertz version. Don't get that. You're throwing your money away. But for $51, it's not terrible. But I really, really recommend for a little bit more money getting something like this. I know it's on sale for $51, but even at the normal like $80 price, I think it's really more than 2 times better than this. The multimeter capabilities is definitely great and very useful. 2 channels, super durable. Stuff's not going to go inside if you throw it in your bag. It is rechargeable. I happen to know on the Zoe, it also has really good standby life. It doesn't drain the battery just being in your bag or whatever. It will probably eventually, but it's not like it drains quickly. And I tend to only need to have to charge this thing every several months, and I use it a lot. And I have a feeling with these things, it's a soft power on. If it was actually a hardware button, that would be better. But since that's a soft power on, you have to hold it. That means there's probably some amount of parasitic drain. I think it's broken. It doesn't seem to turn on. Oh, interesting. So if I push it, it clicks and then clicks again. But I have to hold it. And then it comes on. So to be honest, it might have actually had some charge in it originally, and I just wasn't holding the button down long enough. Okay, that's kind of funny. Either way, this 18 megahertz version should be good enough for me to try to do a repair, so look for that in the future on the main channel, and thank you to whichever viewer sent this in, and sorry it took so long for me to get to this, because yeah, the landscape has changed with stuff like this, right? Now, I'm obviously not going fast enough. This video is going to be a regular mail call and not turbo, so I need to speed up. This package here comes from Stefan in Germany. Hi to all my German viewers. And it looks like, unbelievably, we have another 2023 package. This comes from October 20th, 2023. Feels like little packages like this fell through the proverbial cracks in my big box of packages. Oh, looks like we have some PCBs. Do we have a letter? We do not. Ah, this comes from Stefan, who made the Retro Chip Tester Pro. And we have some improved boards, and I vaguely remember talking to Stefan on email, and Stefan was going to send me some of these, and I was supposed to have done some testing, and of course I have done none of that because this has been sitting there in my incoming package for so long. Oh dear, I'm so sorry about this, Stefan. So we have an entire set of adapter PCBs, some of which I probably already have. Stuart, who sent in my Retro Chip Tester Pro back in the day, the kit, had sent in a lot of the adapters plus all the parts to assemble them. And I think what Stefan had done is said that there were some new adapters and was just going to send me a kit with all of the PCBs, and I'd have to build some of these up. Okay, so everything has been laid out. Sorry, there's glare on those ones there. So we have a 6510 NOP tester, and this is actually not something you would need to use the Retro Chip Tester Pro with, but it looks like you just install a 40-pin socket, or probably a ZIF socket, add some resistors, LEDs, some extra components, and it looks like a USB jack. And then that will almost certainly just run your 6510 CPU in a constant NOP cycle. That's no operation, which probably has the effect of just making sure the CPU is at least trying to execute code, and you'll see some blinking lights with all the data lines. So that's really cool. I don't have a 6510 NOP tester, and here's a 7501 and 8501 NOP tester. This is the CPU that's used on the TED or the C16 and +4 computers. So same thing, just goes through all the LEDs. And here's a 6502 NOP tester. So we have 3 of those. That is awesome. Oh, and a 6809 version here. This is for the CPU that's used in the Coco and a bunch of other machines as well. So that's awesome. And then we have a 6509E NOP tester, the E variant versus the non-E variant of 6809. One of these has external clock support and one doesn't. I can't remember which is which. Or something like that. I don't remember the exact difference, but there's a slight difference. You can't use these chips interchangeably. So we have the NOP tester for these 5 CPUs. Then these look like power boards. So PSU for Retro Chip Tester Pro revision 3. Let me grab my Retro Chip Tester Pro. And in case you're not familiar with this is created by Stefan, and there's the URL 8bitmuseum.de. This is a 2021 revision 1.2. I'm sure there are newer versions now. This thing can test so much, and I need to update the firmware on this because it's running firmware that's kind of old at this point. These are the power supply modules, so there are 2 that are included. This is the power supply module 3.0 which looks very similar to this one. And it uses two different DC to DC converters to create -12 and I think -5 volts. But this does seem to be the same version, 3.0 on both of those. So that's a replica. And then I do have some other PSU modules as well. Looks like this one has some manual configuration capabilities for slightly different voltages. So if you want to drive your chips at 4.8 or 5.3 for testing purposes, you can set some jumpers. This one, is this one software configurable? I can't quite remember because obviously it says 4.5 to 9 volts on that. And then there are a whole bunch of other adapters. And I know I have these already. So ZIP20, this is a type of DRAM package. ZIP16, some chip called a 40103, which I'm not familiar with. So I'm not sure I have that adapter. That might be newer than what I have. This one is the MK28000, along with a couple other chips. The MCM6605. I mean, these are all like really unusual chips, but the Retro Chip Tester Pro can test these, or if these are data holding chips like EEPROMs and stuff like that, it can dump them, or maybe ROM chips, things like that. CDP18U42, a UPD454, and a 464. We have an 8 and 16-bit ROM adapter for larger sizes. I don't think I have that adapter. There's definitely some adapters here I definitely do not have. A 2530, so that's probably some kind of a ROM. A 2716/2532 programmer. That is very handy because these require additional voltage rails, and you can see this has extra power supply circuitry on it for programming these particular chips. And these are old and they can be hard to program. And that's why the Retro Chip Tester Pro is more than a chip tester, can program certain chips as well, which is awesome. So another one that can do PLC-C EEPROMs, and then something for testing or reading 2107 Intel chips, 8155, 8156 zip memory in 256K/1 or 64K/1 zip memory. Chip Tester Pro 1702 adapter. So that's an EEPROM, and it requires an additional voltage rail, which is why it has a regulator on there. And this is just a reader, so you can dump those chips. And I don't have any equipment that can dump these, although I think I have this adapter and I have it already built up, so I can use that. This must be another programmer. Oh, it says right there, 2564 programmer. A 2708 programmer, so another ancient EEPROM type that's very, very hard to program. I'm not sure I have anything that could program that, except I might have this adapter already built up. I can't quite remember, but the Retro Chip Tester Pro can program those. This is a cartridge dumper for the Commodore 64. So if you don't want to open your 64 cartridge to dump the ROMs, which will require desoldering them, you can plug your cartridge into this adapter and often dump the ROMs. TMS 2716 programmer. So another programmer for really old chips, and notice 25 to 27 volts. So yeah, DC to DC converters used on here. 2732. So this one's a little bit easier to program because things like the Mini Pro can program these 2732s, but some of them need up to 25 volts. So you need certain versions of the TL866 or, you know, whatever the standard programmer is. Let me just grab it. I think everyone knows what I'm talking about. It's like this T48. This thing can program the 25 volt chips, but annoyingly, it doesn't support something like the 2716, or no, you know, it does actually. It can, but it can't do 2532s. You have to use something else to do it. The 2532, that particular chip, that is used for like the character ROM on the 64. So, oh yeah, there it is, 2532. I didn't notice this was also for 2532. So that's very handy. So you can program Commodore 64 character ROMs, and that's super cool that Retro Chip Tester Pro can program those. This is the 7412X adapter. I don't even know what those are, but there they are. And a 7481 and 7484 adapter, and a bunch of extra transistors in use there to read and test those, and some CD4098s. And this is a breakout board experimental adapter, so it just allows you to rewire the pinout as needed. VCS cartridge adapter, I'm pretty sure I have one of these. So of course you can dump out Atari cartridges without opening them. VIC-20 cartridge adapter, so again, useful if there's no bank switching or whatever going on inside. SIP tester, I do have one of these adapters, so you can test actual regular SIPs and SIMs with this. Another zip adapter, this time it's for the 4-bit wide variety, 1 megabyte and 256K times 4 bits. And we have a 2513 adapter, so this is a reading adapter, not a writing adapter. The writing ones require like these extra voltage regulation stuff to generate the voltage rails. This is for this 4204, 5404. I don't think I've ever had to try to read one of those before. MK4008 adapter for reading those out. Another zip adapter, 1 megabyte times 1 or 64K times 4 zips. TMS 4050 adapter. and 44-256 and a 44-400 adapter. These are RAM chips. You can do testing with that. Now, as I said, this can do so much more than just testing. It can test tons and tons of parts, but it can dump the contents of many, many EEPROMs, especially with all these adapters. And what happens with that is you hold down the OK button, it actually saves it to the SD card. And then for programming, it's sort of similar. You just use one of the programming adapters, and then you can load the image onto the SD card and then program the chips in this. And this thing just keeps getting so much more versatile as time goes on, like I said, because it's so unbelievably capable. And now that I have like every adapter under the sun, if I ever come across one of those weird chips, I just need to build up the adapter and then I can use this thing. Now, one thing about this particular project is that you can buy the PCBs from Stefan with the microcontroller attached. It's got a AT Mega underneath the screen, and then you have to build up the rest of the board plus all these adapters, and that can be quite a bunch of work. Well, if you live in the US and you want to pick one of these up as a fully assembled set or as a kit with all the components ready to go, so you just have to put it together versus having to order everything, you can order from AmericanRetro.sHop. There are other sellers as well, but there's both the assembled version plus the kit form of this. Keep in mind, it's not going to be cheap. Let's see how much this costs. Now, Jacek and his wife run this shop. Very, very nice people. Yeah, $500 for the assembled one. It's a ton of work to make this. Let's see how much the kit form is. $400 for the kit form. So you could save a little bit of money if you don't mind putting it together, but all the parts are there. And I've had the good fortune to be able to meet Jacek and his wife a number of times at VCF shows, and they are the nicest people. So at VCF Midwest for sure, and maybe East as well, Jacek will be there. Go say hi. You can save a little bit of money on shipping, and there's plenty of awesome stuff that he sells, and support a small local business and get stuff like this there and not have to worry about international shipping, tariffs, and all that kind of stuff. And of course, saving a ton of time. If you want to get one of these and you don't want to assemble it yourself, you can get it from Jacek all assembled. So Stefan, thank you very much for sending in all of these adapters. I'm sorry it took me years, literally years to open up this package, but next time I need to dump some kind of a weird and obscure chip, I should have the adapter here and I can build that up and then I can dump it. And I really need to get back to my Retro Chip Tester Pro and upgrade the firmware on this thing and just really see what it can do. The funny thing is, people ask me to use this more. The reason why I don't, it's not because this product's not good. It's totally good. It's just that when I'm doing instructional videos on teaching people how to fix things, this is a bit of a cheat, like a shortcut. And that's great if you're inexperienced or you fix a lot of stuff and you're just trying to get, figure out the solution quickly. But I'm trying to show what's wrong with something, the fault itself, like with a multimeter or an oscilloscope, where this for me comes in really handy is if I have to dump or program some of those really obscure ROM chips like 2708s. It's just that I haven't really worked on stuff lately that's needed anything that I couldn't just program with my USB programmer plugged into my PC, and that's just faster, obviously, than copying files back and forth to this. So yes, don't use the fact that I don't use this all the time, make it seem like this is not a good product. It's just, it's not great for instructional purposes, which is what I'm trying to do with my videos. Okay, our next package here, this comes from Guy in Pittsburgh, Pennsylvania. Hi to all my Pittsburgh viewers. Looks like we have a note and a whole bunch of PCBs and stuff in here. What is this? This looks like S100 bus stuff. What? Okay. Yeah. Here's the note. Top secret transmission to Agent Adrian. Location Digital HQ, Pacific Northwest Sector. Anonymous supporter of the Retroverse. Classified hardware S100 era technology. You are hereby challenged to revive, restore, and reassemble a working S100 bus computer from the following parts of the Homebrew Computer Club era. An unknown S100 board with a Z80, RS-232, and RAM. We have an SAI RAM expansion board, a Corvus floppy controller, and a brand new backplane. You'll need additional components from power regulation. Zero documentation, zero certainty, 100% chaos. Just the purest essence of early homebrew computing from a box of promise, peril, and potential. Diagnose, reverse engineer this Frankenstein bag of bits, document your progress for your YouTube viewers, review, revive this one-of-a-kind system, celebrate with it freaking works. Unfortunately, this message will not self-destruct. It's now your problem. Godspeed, Adrian. Thank you very much, Guy. That is so hilarious. Wow, I'm amazed by this. I can't believe I've had this sitting around. Luckily, this one's not that, oh yes, it's old. This came from 2024, I think. Let me just check the date on the box here. No, 2025, I typed it wrong on here. Okay, so this is only from maybe like 4 months ago, 4 or 5 months ago. Well, what's really awesome is I do not have any S100 bus stuff at all. And it's definitely something that I really kind of wanted to get into a little bit. And obviously, you know, you could buy an Altair, but that's so expensive, right? Wow. Look at this disk controller. It's so simple. Corvus Systems S100 Rev B copyright 1980. Well, it looks like it's in good shape, but I don't understand how this can do anything. This has an RMA number, so this was warranted at some point, so this may not work. But like, what could go wrong? This is literally just TTL Jelly Bean logic. All of this is Jelly Bean logic. There's nothing on here other than that. So there's not a whole lot to go wrong. Okay, well, there's some bodges on the back. All right, we have a RAM expansion board. Oh, this RAM is in pretty rough shape. And these sockets are notoriously terrible. So these are SRAM boards, 2114s. Luckily, I have tons of those. And this is not a DRAM board. This is just SRAM. So it's much easier to implement. Now, I'm wondering if all this additional select logic, look at all these dip switches. Is this something? There's the SAI brand name. Wow, this is a hodgepodge of parts. Look at this stuff over here. Almost certainly, originally these dip switches, what they were allowing you to do is using this, the 71154. This is a decoder IC, so this allows you to select where in memory the RAM is mapped into. So with these SRAM chips, one of these is 1024 bits times 4. So two of these is 1K. And obviously this board was good for up to 16K if you fully populated it. But back in the day, do we see date codes? 79, 79, 79 on that chip as well. And the SRAM itself, these don't have date codes I can decode. I don't know how to decode these. But either way, in 79, these would have been very expensive. And yeah, I'd say at the minimum to make this work, all of these sockets would need to be replaced. Now, the thing is that's really funny is you could replace all of this with this single SRAM chip. So this is 256 kilobits. And it wouldn't be that hard to just install a socket on here, bodge this into the address lines, the data lines, tie it into the decoding logic, and then have a full amount of memory on this system using just that single chip. Would that be cheating to put 32 kilobytes on a card like this with just a single chip and a bunch of bodge wires? Yeah, maybe. But at the same time, the S100, like, look at this board. It's all about hacking. And hacking that in and just removing all this memory, not worrying about those junk sockets, that would certainly be the way to go. And I think with this chip and some additional decoding logic, we could probably make it work for the Z80 based system that this is. Supposedly the CPU that came with this is a Z80. So we could potentially do it. Now what's weird about this card is I thought that all S100 cards needed to have voltage regulation because S100 does not provide the 5 volts directly on the bus. So that's why we have a 7805 there. So it almost looks like this particular board was used in a system that provided 5 volts directly on that pin, as opposed to whatever normally is coming over the bus. So yeah, some serious hackery was happening. This looks like it had a bunch of diodes and, you know, regulators of some kind for each of the banks. And then that probably supplied this side as well. So this board has definitely been hacked up a lot. Oh yeah, look, normally 16 volts plus and minus and 8 volts. I think the 8 volts is what normally gets turned into 5 volts on pin 1 there. And then I think these other rails are used for 12 volt rails. Look at that scratch. I did not do that. That was already on there. So speaking of the backplane, so we have termination resistors, or we can extend the backplane. So this is a modern board, obviously. Various power supply connections. We have some kind of voltage regulation already happening. We have MSI mounting holes. So I guess this can go into an original MSI case. Altair mounting holes, MSI mounting holes. And these are the original slots. Now these, oh, these are, okay, so see how these have screw holes in them? These are the S100 100-pin slots. That would be for mounting the card slot into the bottom of the chassis so that it's got rigidity. So it's not just relying on the strength of the PCB. This goes in there, you solder it in, and then you screw these into the mounting tabs. Now, of course, you don't have to use a case. You can just run this in a wooden box or something, and I'm sure lots of people did exactly that. Okay, so let's just go through what we have here again. So RAM board, this is the floppy controller. Guy sent along at least 3 of these S100 bus connectors. We even have some of the little guides. So the backplane would be mounted in the chassis and it would have like risers on each side so that when you plug the card in, they weren't just flopping around. They would have had these little risers. Oh, each one of these has the risers. Okay, 2 of them have the risers out of the 3. That's probably something you could 3D print anyways. And then lastly, this is our CPU slash RAM slash, what is it, CPU, RAM plus RS-232. Okay, well, taking a look at this, we absolutely do have our Z80 CPU right there, or Z80, and a clock timer chip. 3884s, I'm quite sure these are serial controllers, so I think this would have 2 serial ports on it. We're missing these chips. Are these the transceivers? No, these are the transceivers there. 1488, and there should be a 1489. There it is. Those are the transceivers. So why is there only 189 and 2 88s? Oh, there's the other 89. So my assumption is we have 2 serial ports. Usually, well, it depends how many lines are used on each serial port. You know, if you have all the signaling or just send, receive, and some flow control stuff. Is there RAM on here? Oh yeah, here's our SRAM right there. This is almost certainly a ROM socket. So you'd have like a boot ROM or something like that that was mapped into the beginning of memory space. Z80 puts the ROM at the very beginning. That way, when you turn on a computer, it will initialize some ROM that would allow you to have like a machine language monitor or something over the serial port so you could communicate with the computer. We have 2 2K SRAM chips, so this has 4K of RAM. And that's what I was talking about with those dip switches on this other RAM board, is we have to map this memory into the memory space after this RAM. So say this supports 2716 for the ROM chip, that's 2K, and then we have an additional 4K, so you have 6K total, and then you want this memory to start after this RAM, so it's continuous. So that's why you have to have these switches configured, or hardwired, I suppose, so that this 8K of memory starts at that 6K boundary. Now with the Z80, things like the clock timer control and the serial ports, these are going to be mapped to the I/O addresses, so they're not in the memory space, so there's no overlap. This is not like a 68502 where you have to have these chips also in the memory space, so you got to carve out I/O space. And interesting is there is another pin header there. I wonder if that's for like GPIO or something? I don't know. It's hard to tell right off the bat what that's for. This could be, though, for remote enunciation of these LEDs, meaning it's just a replica of these signals that you have on a front panel, for instance, because you can't necessarily see these when the system is installed. Dip switches, maybe that configures the ROM, like where it's mapped. There's an additional chip that's missing. It would be cool to find photos of this so we could see what that particular chip is supposed to be, but I wouldn't be surprised if it's somehow related to the mapping of the ROM chip, or maybe the RAM or something like that. The rest of this looks like it's in good shape. We got some voltage regulation happening. 7912, that's for minus 12 volts. That's going to be for the RS-232 that's happening there. LM3404, so that's going to be voltage regulation, and this is going to be voltage regulation, and you know, you have to set up the regulation with the resistors and stuff that are around there. And then we're just checking here. So remember pin 1, that's the unregulated, comes in. It looks like it jumps over to that inductor there. So this one here, L3. And this looks like it's a multi-layer board. So you can see that it's a pretty thick trace that's running under there. And almost certainly that makes its way over to the voltage regulation that's happening here. So right off the bat, the only thing that I can tell is that this RAM board has been hacked away. This is not designed to run directly off the unregulated voltage on S100 bus. So this would certainly be destroyed if this were put into a normal S100 bus computer. But this one and the floppy controller, they look like they're in okay shape. Now, I said earlier that I don't have an S100 bus computer, and that is true. But what I do have is I've been collecting some S100 parts over the years. So I have a couple S100 bus prototype boards. I have 2 of them here. And then I happen to have this card here, which it says Versa Floppy by SD Computer Products. And actually that was it. I thought I had another card, but I looked in my bag there and that was for something else. So this has obviously been modified. We have 2 extra switches there. This has the floppy drive controller, the 1771. Voltage regulation is correctly in place on this board. We have some curious bodges happening on this board. It's in relatively good shape though, so that's something. And what's cool about this board is that 2 connectors, 2 edge connectors, one 50 pin for 8-inch drives, and this is probably 34 pin, so that'd be for 5¼ inch drives. This one has a normal floppy drive controller. That means that this is more likely to work than that Corvus card. This one probably requires the operating system to literally bit bang the floppy disk interface. Meanwhile, this one obviously has a normal controller that does a lot of the data decoding and stuff. So this is going to have a lot more smarts and be more likely to work with CPM, which would be the operating system we'd almost certainly use on that Z80 card. So I think with this, plus that CPU and ROM and RAM, and then the RAM card hacked to support more RAM, we could potentially get 62K of RAM. I mean, it depends how big the ROM is on there, or if it's a 4K ROM, we get 60K of RAM, and the other 4K would be for that ROM. And yeah, I get S100 bus up and running. How exciting would that be? Build a wood case for it. Oh, this is very cool. I'm rebagging everything. I'm going to put this letter in with the backplane board. And I mean, at some point in the future, this is frankly exciting to me. I find this kind of stuff really quite cool, just because the fact is the first S100 bus computer, the Altair, was a kit originally. And then, you know, there were plenty of off-the-shelf ones. But I think many people home built their own S100 bus computers because these cards started coming out from third parties and people could make their own backplanes, you know, and wire wrap them and their own cases. And there was just a whole community around making these types of computers back around the year I was born, 1975, 1976, 77. And then, of course, computers like the Apple II and the PET and the TRS-80 came out, and people building these just sort of fell out of favor. But still, the whole idea about being able to make your own computer from scratch, basically using this kind of stuff, is so freaking cool. And I suppose if anyone has any leads on other S100 random stuff like this, then this could all potentially go into this fancy new computer. And if I want to add more cards, I just need to get more slot connectors, because currently we only have 3, so that's only enough for 3 cards at once. But like I said, if anyone knows more about that Corvus floppy controller, and if it's even usable, let me know. But that other one that has that 1771, I think that's going to be more usable. I don't know, there's going to be a whole lot of work involved to try to get a computer like this up and running. Back in the 70s, people had time on their hands. You didn't have the internet. We didn't have social media. You didn't have smartphones. So this stuff was where it was at. Very cool. Okay, here's our next item. And the weird thing is it's already open, and I wrote who this is from. But the funny thing is, I don't have it on my spreadsheet on my laptop here. So I guess I never showed this, and I don't know when it's from either. But this comes from the Mad Haxer with an X, like hacker with an X, from Newcastle. And that would be in the United Kingdom. The funny thing is, I really remember showing this before, but maybe I didn't, and I'm just misremembering, or maybe this was in that footage that I haven't edited up yet that I mentioned in the intro. So what we have here is a Sinclair ZX81 clone that doesn't use the ULA chip, and that's that custom Ferranti chip. This board gets around that by using all discrete logic, which is why it has a lot more chips on it than the original machine. And you can see there's ZX Spectrum Harlequin Rev G. So this is for people that just need to replace their ZX Spectrum because there was some kind of an issue. So it makes space for all the TTL logic. We have regular SRAM, so that's at 32K SRAM again. We have the ROM, there's the CPU, an original Italian one, and then there's another SRAM chip here, so that's a total of 64K, but I think it's just 48K, and that extra amount is unused. And then we have tons and tons of TTL logic. Now, one thing I'm noticing that might be problematic is this is all HC logic. Now, HC logic is not good to use in old TTL systems. This is obviously a TTL logic chip. The rest of this is fine. It's just the CPU may not be compatible with HC logic. Looks like everything is HC logic. I recommend using HCT logic, that's TTL compatible, or ACT, or just original LS, which you can still get all of that stuff. But yeah, I stay away from this LS stuff entirely. Now, I've worked on Spectrums a little bit, and I might have to reach out to Lee over at More Fun Making It. Lee probably knows a lot more about this than I do. What's this? This says 4016, but this has got to be a resistor pack. I don't think that's a regular IC. It does say U7 on it, though. Now, I recall when I got this thing, this was all hand assembled, as you can see, and I recall the Mad Haxer telling me that this never worked properly. You can see a little bit of rework here and there, and I haven't gotten around to ever trying to test this thing. And this would definitely be something I need to reach out to Lee about, because I just know so little about this particular Harlequin system, and probably need to first figure out if it works with HC logic that's in here. It probably does, but just in case. And then we have to find where the fault is with this. Hopefully for the Harlequin though, I don't know if it's open source, but maybe the schematics are available, and that will allow us to more easily trace, where all this stuff goes. And a 2-second Google brought us right to, there's the PDF for the entire Harlequin system. Okay, that's awesome. So that should make troubleshooting potentially easier. It specifies all HC logic. That's kind of curious. I wonder if there's a reason for that. Either way, I think it would be a fun exercise to get some kind of diagnostic Z80 ROM in here and then try to start to figure out what might be going on. Is it executing code? Do we have good clock? Voltages are good, you know, all that usual stuff. Reset circuit, video out. Where's the failure? It can't be that complicated, even though this has got a lot of TTL logic on it. It's certainly less logic than an Apple II has, for instance, and this does output color, and it is a full 8-bit computer. So it's pretty cool that it's all condensed into this small little board that does fit, as far as I'm aware, in the original case for the ZX Spectrum. So thank you very much, the Mad Hackster, for sending this in, and that will be for a future repair project. All right, so our next package here comes from, I think this is Levi. This is a t-shirt, obviously. Yep, there it is, from Levi. Great to meet you at VCF Southwest. That was in Dallas. Thanks for the interview for my channel. Enjoy the shirt, Levi. And that's Levi's channel here. And the interview, which I will find and link below, I think I shared it on my Bluesky at some point in the past. Levi did an interview with me at VCF in Dallas last time. And basically we were talking about the fact that how the YouTube landscape and people like me who are just like one-person shows are kind of changing the landscape of what people consume as, well, from an entertainment perspective. We used to watch TV shows that were made by production companies, by Hollywood, big companies with huge teams and big budgets, and now it's just one person with a camera, video editing, a microphone in the basement, making content that people watch every week. It was a fun interview to do, and it's just neat knowing that I'm one of those people that's kind of on the forefront of this changing world that we're in, making content. Oh, I almost forgot these little things. These go with the Retro Chip Tester Pro boards. I need to make sure I put those with it. But anyways, I'm on the forefront of this changing entertainment landscape. Cable access 2026 version. That's this channel, or these two channels right here. Thank you very much, Levi, for the shirt. Let's pick another item. Okay, all right, so we got something here that's kind of heavy. Comes from Ted in Lake in the Hills, Illinois. Hi to all my Illinois viewers. Looks like we have some periodicals or publications. Computer shopper. I'm gonna have to do a dedicated video, I think, for this stuff. Oh boy. It was on old mail call episodes where I would really spend time to look through this. Adam Osborne, Chuck Peddle, Bill Gates, hello, Clive Sinclair, and 47 others, they speak out. 10th anniversary edition. I have no idea if any of these periodicals have been scanned, but this is certainly something that will need to be scanned if it's not. Oh, look at this. All the ads. Oh, 10 meg hard drive by Quark for your 2C. How did that even hook up to the 2C? If you have a 2C or a Macintosh or a 128K Apple IIe with a duo disk dual drive, you require no additional accessories. The drive plugs into your disk drive ports. It was $2,000 in 1984. How did this work? Oh, there's so much good stuff here. Software listings, you know, Electronic Arts, music instructions for the C64, your price, $31.94. Disc ads, oh, this is amazing. I mean, I can't look through all this right now. This is a turbo mail call. And we have a 1982 August edition of Popular Computing, Japanese computers, what's coming and what's here. Wow, the NEC PC 6001, the Fortune 32:16, the Omnicolor 640 printer. There's the good old TRS-80 Model 2. Okay, I'm spending too much time. That is cool. Money magazine from 1982. William Gates, 27, who made millions by creating the basic language of small computers, tells you what to get and what to watch out for. Yeah, you know, if you have a picture of a CRT, by the way, you always have to have someone leaning on the monitor or have their hand on top of it. It's absolutely a requirement. USA 1 is taking charge. What? Oh, booze advertisements. I don't think you ever see that anymore, do you? Look, there it is, the buyer's guide. And we have the Apple II Plus and the Franklin Ace right here together. So $2,600 with no monitor, $2,500. So this was more than this? That's not possible. I guess it did have more RAM. What's funny about the Apple III in this one is it looks like it has a white phosphor screen, even though it should be green. And look, that's white. Oh, I guess that's also Well, it's the same monitor, isn't it? Did this come in a version with white phosphor? Interesting. That's the Apple III monitor, by the way. Look at the Corvus concept with a portrait display monitor. That's so fancy. And a deck rainbow. Time Magazine Machine of the Year. The computer moves in. 1983. Oh, I love smoking advertisement. Wow. Reach out and touch someone. Bell System. Yep, that was their little motto back in the day. There's someone using an Apple II, and it's one of those NEC monitors. I recognize it. Keeping up down on the farm. Missouri rancher wife Melissa Beckett uses her computer to update records on 350 cattle. Do you think Melissa was actually using the Apple II plugged into an extension cord on the back of a pickup truck or whatever, this Dodge Ram or something on a farm? Learning how to use new tools. There's an Apple II. There's one of those Zenith monitors. Nice. And look, one of these CRT projectors in color running one of those basic demo programs. Oh, so much good stuff in here. It's like a time warp. And then, of course, we have Computer Shopper. And this is later. It's from 1988, but I have memories, just so many memories of this. Look at that AT&T computer. Look at this. I flipped it right open to this Magnavox 14 multi-mode display. So these monitors, these are the bee's knees. If you could get one of these now, you'd be in great shape. So it does 14 kilohertz, EGA, CGA, MDA, Hercules, probably supports analog as well. So 640 by 480 without cord. Wow, cord? Cost that much? Anyways, Macintosh compatible. So analog RGB plus digital RGB. It probably has composite input as well. It costs a lot. Look at the price of these monochrome monitors in comparison. But this monitor would work with everything. And that's what was so great about it. There were other monitors like this as well. We got Macintosh accessories as well. Hard drives that go underneath it, external clone floppy drives, the first 800K floppy drive introduced for the Mac Fast Quiet, compatible with the 128, 512, and Mac Plus. I wonder how that worked exactly. Of course, Computer Shopper is going to be filled with clones. And look, OS2 approved. Yes, these two, OS2 approved. Oh, this is just a gold mine of information. I mean, sadly, it's mostly like ads selling stuff. It's not technical info. So that means that, we're not going to find like information about drivers or dip switches and things like that. But it's still neat to know prices and whatnot. I think some of these have been scanned, but I think a lot of these haven't. Because one of the problems is, I mean, look at the size of this. And most of these Computer Shoppers were purchased, used for prices, and then you had to replace it because the problem is the prices would be out of date very quickly. Things were changing so quickly back then. Look, build your own Amiga hard drive. So, no one kept these. I never kept a single one of these. I would just toss them out and I'd get a new one and I'd have it kind of as a reference for prices. And every time I'd pick up a new one, I just toss the old one away. So that's why not a lot of these have been saved. It's not like someone has a library that I'm aware of with every single one of these. And I don't think anyone has scanned these. So dual frequency, this has RGB separate input, mode 1, mode 2. So this was not support the analog VGA, stuff like that resolutions, but it does support EGA. Have I done a video on this monitor, by the way? I think this is actually, yes, I think I have. I think what's inside of this Samsung CD1453Mi is the IBM model 5154. The IBM EGA monitor, it's made or designed by Samsung, and what's inside of this is the same. I think I've done a video on this monitor, and that's the CGA version, lower resolution. Anyways, like I said, this is freaking cool. So Ted, thank you very much. I could go on for hours, and if anyone wants to see me make a special episode with these magazines and really go through them, or even just the Computer Shopper just to kind of peruse it, let me know. I could probably talk until my voice is sore going through these. So yeah, Ted, thanks very much for sending those in. Awesome. Right, our next package comes from John in Kamloops, British Columbia, up in Canada. Hi to all my BC, Canada viewers. I wonder if this is John from CelGenStudios. If you haven't seen John's YouTube channel, absolutely super fascinating stuff that's on here. John is really into really obscure systems, and his channel is extremely fascinating and very much underappreciated. Not that many views on a lot of his videos, which I think is a travesty. I met John from CelGen a number of times because he comes down to Seattle at those events and VCFs and stuff as well. Very, very nice man. And let's see what we have here. Computer Holy Wars. Hold it right there, buddy. What's happening here? That scruffy beard, those suspenders, that smug expression. You're one of those condescending computer users. Here's a nickel, kid. Get yourself a better computer. And there's a nickel. Yeah, okay, so it is John from CelGen. And that's it. That's what's in here. Thank you very much for that, John. This came relatively recently. This actually, I got this right at Christmas time this year, the Christmas that just passed. So yeah, thanks, John, for sending that in. That is absolutely hilarious. Like I said, if you haven't seen John's channel before, I highly recommend it. Very, very interesting. Wait, there's more in here. I almost threw this away. This is the reset button for the Lisa. Oh, John. Okay, so let me grab the Lisa. Here's the Lisa. There's the reset button that I put in because I didn't have the right one. If you look down there, it's connected with some bodge wires and hot glue. But it works. So that's the reset button I have on the Lisa. But John obviously had the appropriate one. And there it is. So this is the original one. And if you watched the Lisa series, well, the problem is with the reset button, it was on the original Lisa board, is of course this was so damaged by the battery, the reset button was completely destroyed. And well, there's the replacement one. So yeah. John, I really appreciate the switch. Thank you so much for that. And the funny little note here with the nickel. I love it. I absolutely love it. The next package I have, and I'm gonna have to end this video soon because I think it's getting kind of long. This comes from Aaron in Cumming, Georgia. Hi to all my Georgia fans. Ah, yes. Okay, I remember what this one was about. So this is a Cool Boy 401, one of these clone Famicom cartridges. Please find this Famicom 401 cartridge. It's my go-to cartridge for the Famicom. Okay. I found one of these years ago and recently got a hold of another one. So I donated this brand new one to the basement. Enjoy your content. I was the guy that got you the shirt. Ah, yes, I remember. It says on the letter here, this comes from Skip, actually. So that must have been the from address was actually just whoever shipped it. Anyways, I remember you, Skip, grabbing the shirt, running off and getting the shirt and coming back and giving it to me. And then, you know, you had to say goodbye and take off like you were leaving for the day, or I was leaving for the day or whatever. That was that 2 years ago or was it last year? I think it was 2 years ago, wasn't it? Either way, this is super cool. Next time I do a video with Famicom support, and I did order another Famicom, another clone one, so that's coming. So this will be perfect to test at that point. I kind of love these cartridges because it's filled with like weird games and stuff. And it does seem like the community has spent some amount of effort to extract the weird games that are on here, so you can have those NES files to play with your EverDrive and regular NES cartridge. Obviously, this works on Famicoms, and to use it on a front loader, you need to have an adapter, and this goes in upside down and stuff like that. This weighs absolutely nothing, but it looks like it's in mint condition. So Skip, thank you very much for this awesome multi-cart. I may end up playing a little bit of this myself upstairs. I have a Famicom. I'll plug it into my 1702. And I may not be able to resist not playing with this, but I'll definitely show this off next time I have a Famicom down here on the bench. Let's do one more package. This one is an Amazon drop ship. We have a gift note. Hope you get some use out of this. The right tool for the right task from Dave Carroll. Thank you very much. And we have a few actually. Oh, that's just gift receipt stuff. Okay, I think that's it. We don't need to look at the rest of this. That will spoil the surprise. Yep, that would be just in case we need to return some of these things. This is obviously in response to my Apple 400K disk drive video where I was having trouble pulling off stir clips. We have this Japanese engineer PZ01 long life box joint structure to avoid loosening. Okay, I don't know, it doesn't really matter about that stuff. Stainless steel. And this is obviously for removing freaking circlips. It's so freaking cool. It feels very nice in hand as well. So I'm trying to see the way this works. Okay, so the way this would work is you would go down onto the circlip and then you could pop it off. No, okay, I see. So, well, at least for reinstallation, you can grip it and then push it on. Oh, that is so great. That is great. And I guess the tip is magnetic as well. I'm sure there will be people who can tell me how to use this, that if this tool is just for installing the circlips back on, or if there's a way to get them off as well. Or do you just get them off using a pick like I was doing? Which is probably the case. And getting them back on was scary because I was afraid, not using the right tools, using needle nose, that I might have like flipped them off and then they'd be gone forever. So this is super handy. And then the other thing I was complaining about in that video is that I didn't have any of these for use in my sonic cleaner. So this would be putting all the loose parts like screws, fasteners, the circlips themselves. I could put them in this and throw this into the sonic cleaner for getting those parts clean. So you don't want to just let them go loose inside the cleaner, because then you could dump it out and lose those. So of course these are for loose leaf tea normally. I don't know what this larger one would be for, but they've gotten a little squished in shipping. Amazon did not do a great job of that, but maybe I can just pop this back. Yeah, I can just pop this back into shape. Very, very, very helpful. I have a couple sonic cleaners. I have a large one that can hold big circuit boards, and I have a small one for little parts like the floppy drive parts. And these are great. Yeah, I don't drink loose leaf tea, so I just don't have any of these. And having a few of these will be perfect for getting those parts nice and clean. And this for the circlips, for next time I service a floppy drive, this is awesome. Okay, why don't we do one more, since those were just little small items. This one comes from Andreas in Switzerland. Hi to all my Swiss viewers. A country I have not yet been to. Or have I been? No, I haven't really been to Switzerland. I flew through Switzerland once, like I had a layover there. So I was in the airport, but that doesn't really count because I wasn't outside of customs or anything like that. So this is a RAM tester for two different types of DRAM. So we can test zip memory, use the zip or the socket, not both. And then we have some switches. I wonder if this is the same person who makes this as makes these RAM testers. I just dropped the other one. I have two of these testers. Here's the other one. These were sent in by a viewer. So Simon made these. These didn't come from Simon. These came from another viewer. But I'm curious if it's the same person that makes this, Simon as well. Okay, RAM tester for vintage Commodore computer RAM chips. Oh, interesting. It says Commodore, but I'm wondering if this is just 4416s and 4464s. And all right, yeah, so Hackaday, cheap and aggressive DRAM tester, open source DIY solution. It looks like there's a version that isn't this one that does support a screen. That's interesting. So what is this tester? So most testers require 2 minutes or more for single 41256. This project completes a full memory, address, data line, and retention time test in 15 seconds or less. It is probably the fastest Arduino tester around and can also handle the zip packages. Most tests are less than 10 seconds, rapid diagnosis. I wonder if it does like really thorough testing or whatnot. Different chips. I wonder what kind of chips this supports. Optional LED blink codes or OLED screen. Here we go. These have a 1, because these require 12 volts and 5 volts like this other tester can do. But this one doesn't. That's a 5 volt only version. And this is 5 volt only. That's a 4-bit wide. Well, this is very smart. If you could just put in 4-bit wide chips and 1-bit wide chips, and it figures out exactly how it works. And zip versions. So time it takes, 30 seconds. If you're testing the 1 meg by 1 version and 1 meg by 4, 16 seconds. Interesting. It tests for shorts from power supply and ground, decoding faults, stuck cells, crosstalk, random patterns. You can build your own, or you can buy them. And there are various sites here. You can check out this repo, which I'll try to put in the description. Let's go back to the top so you can see the name of it one more time. RAM tester by Tops4U. Let's give this a connection and we'll give this a test. We find a RAM chip to plug into here. I think I have some RAM chips on here. Okay, I do. So this one here is a 4416. I know the part number doesn't quite look like it, but this is a 4-bit wide 16 kilobit chip. Okay, so we'll put this chip in there. Reset. So I assume that means it's testing. Oh, okay, chip is good. That's fast, and that's very cool. Let's see here. Here's a 4164. I know it says 4264, but let's test this one. This is what a Commodore 64 would use, for instance. So we pop this in and we hit reset. Although maybe I need to reconfigure stuff. I didn't even think about that. Test procedure, connect the power supply. It says here, use dip switch to set the number of pins your module has. Only one switch may be on position at any given time. If none or more of the switches is on, a spanner symbol and dip switch settings will appear on the display. Oh, you know what? Look, because of the way the light is casting a shadow, I can see now what it's asking about here. So this particular chip here, so we'll just unplug the power here. So what it's looking for is 16. That's the number of pins on this thing. Okay, now I get it. So we just plug this in. So it looks like it goes from orange to green, red. So running test, Orange is solid, could be flickering a little. And then when it's done, red should not be coming on. We should get 1 flash for 16 and orange for affected subtype, see below. Green, orange, 4164. Well, I mean, that's not orange. That's red. I know it's hard to see in the camera, but it's totally bright red. That's orange. Both lights are on together. Green, green, red. Well, let's do a quick test. I'm going to take the RAM out, and we're going to put the button. It should flash, slow flash, red, no RAM. And that's exactly what we're getting. Orange, green, red. And that doesn't really make sense because it's saying that it should be orange. So green, orange. The only time it's green is when the test is okay. So should this be 1 green, 1 red? I'm thinking that's the case. I think there's just a problem with the documentation, or the firmware that's on here is maybe older. I don't know. Well, I think I've sort of fiddled around with this enough. I don't really get what's going on. The color codes don't make sense. So if Andreas, who sent this in, or anyone else watching can tell me what I'm doing wrong with this, please comment down below. And I think with that, that's going to be it for this video. I just looked at my spreadsheet. I've opened up 12 items in this video, so less than last time, but I've done more talking. I really need to speed up my opening because the pile is dwindling there, but there's still a lot of stuff in that pile, and obviously I need to get through it. I really, really need to get through it. But thank you very much to everyone who sent stuff in for this video and that stuff there and the last video. The generosity of my viewers are just absolutely amazing. And if there's things in this video you'd really like to see me focus on, please comment down below because I need some input to see what I'm going to look at next on the main channel or maybe on a second channel video. And then I need to keep making these videos so I can get through all of this stuff. I got to get through it. So that's going to be that. So yeah, thanks to my supporters, thanks to my subscribers, thanks to you, thanks to everyone, and Happy New Year and happy holidays, and stay healthy, stay safe, and I'll see you next time. Bye-bye.